exercise 21.5, question 5. So in this question, we are given the equation of a projectile, which is y equals 1 plus 0.16x minus 0.008x squared. And we are told that it's projected from a point P and it hits the ground at a point Q. And this is our x-axis, this is our y-axis. And in part 1, we're asked to write down the height P and find the coordinates of Q. Well, the height P is clearly when x equals 0. We can see when x equals 0, y equals 1. So P is the coordinate 0, 1. And Q occurs when y equals 0. So when y equals 0, we have 0 equals 1 plus 0.16x minus 0.008x squared. And that's just a quadratic equation for you to solve. And actually, if you multiply through by 125, this becomes, so multiply both sides by 125, this becomes 125 plus 20x minus x squared. And then, actually, if we multiply through by minus 125, we end up with 0 equals x squared minus 20x minus 125, which does factorise to x minus 25, x plus 5. So x is either 25 or negative 5. And this context is clear that x is greater than 0, so it must be that x is 25, so the coordinate of Q is 25, 0. Okay. In part 2, we are asked to find the horizontal distance x from P at the highest point of the trajectory and show that this is 1.8 metres above the ground. So we're interested in this point here. And what we're asked to find is the horizontal distance here, which is the same as this horizontal distance here. Okay, well, if we're thinking about this here, this is the stationary point of the curve. And this is actually, it's a quadratic, so we could either complete the square if we wanted to, or we could just differentiate. So what we want to show here is we want to find the point where dy dx equals 0. So if we differentiate this with respect to x, we get dy dx equals 0.16 minus 2 lots of this, so 0.016 x, and we know that at the stationary point this is equal to 0, so therefore 0.016x equals 0.16, so x is 0.16 divided by 0.016, which is 10. And we're asked to show that at this point here the height is 1.8. So all we need to know is when x equals 10, y is equal to 1 plus 0.16 times 10 minus 0.08 times 10 squared, which is 100. Well, that's something we can calculate. That is 1 plus 1.6 minus 0.8, which is 2.6 minus 0.8, which is 1.8 meters as required. Okay. Part 3. Part 3 says find the time taken for the projectile to fall from its highest point to the ground. There's lots of ways to approach this. But I think one way you can approach this is by thinking of a new projectile that just goes from its highest point to the ground here. And we want to find how long this projectile here takes to reach the ground. Well, let's say that this has initial velocity here of, well, initial speed of u, but we know that it's at the highest point. The only component it has is the only non-zero component of its velocity is the horizontal component. At the highest point, the vertical component of its velocity is 0. So from this point here, which is the highest point, we can say that the initial velocity is u0. The acceleration is constant, and the only force acting is gravity. And we know that it has a displacement. Well, we know a bit about this displacement because we know from part 2 that this height here is 1.8. And we also know from part 1 that this distance, so from part 2, we know that this distance here is 10, but we also know that this distance here is 25. So that means the distance we are interested in is 15. So we know that this distance here is 15. So what do we know about the displacement when it hits the ground here? Well, we know its displacement r is 15 horizontally, and actually it has gone down by 1.8. So if we put that into our SUVAT equation, r equals ut plus half a t squared, we get 15 and 1.8 equals u0t plus a half 0 minus g t squared. And if we read off those two components, well, actually this should be a minus 1.8, which is the one we're interested in. In this question, we want to find t. Well, from the horizontal component, we get 15 equals ut, and there's two unknowns there. But from the vertical component, we get minus 1.8 equals minus g over 2 t squared. So actually we can solve that for t. We get there times by negative 2, so we've got 3.6 equals gt squared, and we're told in this question we can use that g is approximately 10. So actually we've got t squared equals 3.6 divided by 10, which is 0.36. So t, and it's a positive time, is the square root of 0.36, which is 0.6. Okay, in part 4, we're asked to find the horizontal component of the velocity. And deduce from this the time of flight for the projectile to travel from P to Q. Well, what we need to remember here is we're going to go back to the original projectile. So we're not talking about this projectile anymore. We're not modelling it from its maximum height. We are modelling it again from P to Q. However, what we do know is that the only force acting here is gravity, right? So the only force acting here is gravity, which acts downwards. There is no force acting horizontal. So that means that there is zero acceleration, so the horizontal velocity is going to remain constant. Well, in the last part here, we noted that 15 was equal to u times t. Well, if the only force acting is vertically, then this u here the component of velocity at the maximum point, the horizontal component of velocity at the maximum point, is the component of velocity at all points. So what do we know at the maximum point? We know that 15 equals ut. But we've just calculated t at the maximum point, so we can say that actually the velocity at the maximum point, 15 equals u times 0.6. So the velocity, the horizontal component of velocity at the maximum point is 15 divided by 0.6, which is 25. So that means that our velocity here at the maximum point, that horizontal component, is 25. But that's going to remain constant throughout because there is no other force acting at all. Okay, so what can we do from here? We now know that the horizontal component of the velocity is 25 meters per second. Well, if we think about the displacement here and the displacement here, what do we know? Well, we know that from here to here, we knew that this height here was 1 and this distance here was 25. So if we're going to take this as our origin, then we know from here to here, we know the displacement is 25 and negative 1. And what do we also know? Well, we know that u is 25, but we don't actually know the vertical component of velocity, so let's just call that v. And all we're saying there is at this point here we know the horizontal component is 25, the vertical component, we've called that v, we don't really know it. We know a, we know that is 0 minus g, so putting that into our Suvat equation, r equals ut plus a half a t squared, we get 25 minus 1 equals 25 a v, lots of t, plus a half 0 minus g t squared. And we don't actually need the vertical component here, we can just take the horizontal component, which gives us 25 equals 25t, so t is 1. So that tells us the whole projectile from P to Q takes a time of 1. Okay, the final part, part 5, asks us to calculate the speed of the projectile when it hits the ground. So, what do we know here? Well, we don't know the speed of the projectile if it hits the ground. That is our, and if we're going to model the whole projectile, let's think about what we do know. We know r, we know that that is 25 minus 1, taking this point here as the origin. We know t is 1, and we know a is 0 minus g. So we can actually use the Suvat equation, r equals vt minus a half at squared. So putting those vectors in, we get 25 minus 1 equals, let's split this into components, so vx and vy, lots of t, minus a half of 0 minus g t squared. But we know these t's, we know those t's are 1, so t is 1, and also t squared is also 1. So what can we learn from here? Well, we can write down two things. We can write down 25 equals Vx, which we knew already because we know the horizontal component of velocity is constant, and we also get minus 1 equals Vy minus a half g, so plus g over 2. Well, what do we want to find? Well, we can solve this here. We're actually using g as approximately 10, so minus 1 equals Vy plus 5, which gives us Vy equals minus 6. So we know the velocity with which this hits the ground, so that is this vector here, is 25 minus 6. But actually we're not asked for the vector, we're asked for the speed, so we need to find the modulus of v. Well, the modulus of v is just the square root of 25 squared plus the square root of 25 squared plus minus 6 squared. Well, actually that ends up being approximately 25.7 meters per second.